All right. Can you hear me all right?
Yes,
yes seems like it. I'm going to talk a little bit about Electron and how we implemented it at my project. It has been an uphill battle. Being a new or a fairly new developer, there's a lot of things I don't know. I have 2 years experience, and I'm primarily a front-end developer. My name is René, and handling concurrency is not something I've done earlier. If you build
an app, it would try to do something with another window and vice versa. And this ended up making things really, really hard to read.
The login window, which loads a Auth0 web page. And in that window, we says create main app window, which means that we would always have to go through the login window to make that the main window. And if you want to close the main window, you have to go back to the login screen and do some cleanup. So this way, we coupled it way too much and ended up with very hard to read and very hard to understand code. And my theory back then was a hypothesis was that you should rather go for an event-driven programming way and use custom events such as successful login and handle all the inter-window events on the outside. So we opted to go for an orchestration kind of way of doing things. We used a browser window. You don't have to do it. It can be any kind of event emitter or function. But we use a browser window because it also lets us keep the app keep it running. And because Electron does have something called all windows closed event, which is if there's no open window, it will terminate the app. This is a reasonable way of doing it, because if you close all the windows, you should probably expect it to be closed. On Mac, however, it is usual to keep it in the docking and be able to reactivate it. So there are some differences in how you usually do this. But we chose to keep a single browser window as our orchestrator and use that one to keep the app from closing. So it's not able to be closed by the user. And it handles, at the moment, most of the calls that goes, most of the handling of the other windows. We got very far, but we didn't get all the way. So this is our orchestrator window at the moment. It takes in the events that's sent by an event emitter, usually a browser window, and does some handling based on that. When I was first trying to implement this, we had this long a list, but we had to roll back a lot of it because we ended up in a deadlock. And that's my fault for not knowing how to do things. Another thing we had to learn quite fast was garbage collection. I have never, ever had to think about this before. I used Electron. But if you don't have a globally reachable reference to a browser window, it will be garbage collected. So it suddenly just kills your window because you no longer have the reference. So we ended up putting all our references in a global object. And we keep this up to date at all times through our orchestrator. Our big goal was to do as much blackboxing as we could and say that one browser window should not communicate with another browser window at all unless it's through the orchestrator. It should only care about its own stuff and should be, yeah, I do this. Oh, can you do this? Yep, I did it. That's all the communication that should go. But we have a small leprechaun on the side that says, you forgot to fix this somewhere, so I'm going to ruin something over there. And it was especially 2 weeks ago, or 1 week ago, I found that we had forgotten to remove a reference to one of the windows somewhere, and you ended up having several events that went over each other and destroying another window before you were trying to do something else and causing a bug. Very hard to find bug. So if you don't keep it really black boxed, you will have a lot of bugs it's hard to find. Another thing we found ourselves is that because we are dependent on a lot of asynchronous stuff, so you have to do an HTTP call to this server to get some configuration, you have to check if your hardware server is up, we ended up having async-await all the way down. So you end up basically in callback hell again. You're back to where we started, but it's at least slightly easier to read. And it's especially the hardware server that was making this hard. Because originally we were using signaling, and we had to implement a REST interface instead for shutting it down. But I'm getting a little bit ahead of myself. As it stands at the moment, you will have to wrap your top level function as an async function, because you have to have an async function to do await. So when we try to start the hardware server, we have to await for it to be done, and then the top level function has to be asynchronous. It is I think it's in stage 3, this top level await, which is coming soon, which makes you not have to wrap your entire program in a single asynchronous function. But because we were wrapping everything in async and not knowing exactly what I'm doing, we ended up with a deadlock. And this was really, really, really hard to find, so I had to roll back. I couldn't find it at all. And it showed me a big missing thing about how I work. I usually do debugging through logging. That's not good enough. I have to learn to use, say, VS Code's internal logging or debugging tools. So this is something I'm looking into now, and hopefully we'll learn fast enough. And as said, we used signaling for trying to turn off the hardware server. So we started it as a detached process and just kept the process ID and said, kill this process ID when you're done. But Windows don't support signaling. This is one of the things I found in Node.js that was just a small line in the documentation. There's no big note or flag that says you need to know this. It's just hidden far down. Everything is simulated as if it is a SIG kill, because Windows don't have this. This ended up with the Spring Boot server, because we have said that it should save a application PID file so that we can pick up the PID number without doing any heuristics. But that file was not deleted because it was just plain terminated. So when you try to start a new server, the next time you started the app, you ended up with, hey, I can't start the server. There's already a file and I don't have the rights to actually remove it. And it was also a far-fetched bug to find. So as said, we ended up making a shutdown endpoint on the server, and now we are awaiting this response and saying just, hey, are you open? Are you open? Are you open? Are you open? For 20 seconds. If it doesn't answer, it's like, okay, good, you're actually dead. We used a packet that was named wait on. It had a bug that if you called it from an asynchronous function, it would resolve its promise, but it would never terminate. It kept just calling. So it was spamming our server for like 10,000 times an hour. It was really annoying. So we re-implemented the whole thing ourselves. There is some fix out at the moment, as far as I know. It's trying to make a version 4 of it. I haven't had time to test it yet. Another bug we found this week is page navigation. This, when you open a browser window, you say you load a URL, and on the first load, it usually don't give a page navigation event, unless it's Windows 10. Then you get the first load as well. This caused a problem where when we logged into auth0, you would have the redirect URI, and we hadn't whitelisted it. So it said, hey, no, you can't go here. So we would open the redirect URI in the browser instead. And this is the common way of doing security for Electron. Because you have operating system level access, you have to be really sure about what you are actually taking in to execute in a browser window. Because if there's anything that gets access to the node stack, you can take anything from your disk. So we are whitelisting whatever you want to, or whatever we need to access in the browser window, and only let those be opened. And when we found this bug, it's like, okay, we have to put Microsoft Online in here as well. On Mac and on Windows 7, it doesn't give the event at all. I don't know why, but we found it. So it's especially the will navigate event that will happen on the web content that is loaded in a browser window. Also, another thing that is quite infuriating when you're trying to understand what is happening. You expect the ready event of a browser window to actually be shown or be emitted. But a lot of the events that are emitted by Electron have some requirements, and it's not necessarily easy to see. The documentation is quite good, but not perfect. So if you want the ready event, you have to have the browser window to be not shown when you make it. When you instantiate your window, it has to be show false, unless it will never give you the ready event. It's really counterintuitive, but it's there. So it's like, yeah, I'm listening for the ready event. Why isn't this firing? And it took me probably 2 days to find it. And there's also the close event. You have several different ways of terminating a browser window. The ordinary way is using the close. And it will send the close event, so you can handle it, and usually you use it to hinder it from logging out unless the user actually wants. So you usually give him a dialog, say, do you want to log out? Yes, no, and then you move on further. But you can use the destroy method instead, and this skips the closed event. It goes straight to closed. And then you can use it to your advantage. We are. And when I was looking through the code the other day, I was wondering why I don't use the on before unload event, which is the recommended way of stopping it from closing, but I haven't checked it further. So there's a lot of events that have requirements for how and when they will fire that you will have to read the documentation to understand. And on the other side, there are events that you don't expect to happen that really happen way too often. Say if you want to close the application. On Mac, you usually use Command Q, and it should go away. The thing here is that the Electron, I would say, internals, sends the close event to every single browser window you have. Which means if you have one window that should handle the actual close event, it can be stuck in queue behind a different window. So for this we show a loader screen whenever you move between windows. And we never terminate this window to keep it there all the time. It's faster to show it again. So when we tried to close the window when we were at the login screen said to the splash screen, no, show yourself. And it was still in the block, the block for the login screen. And the close event on the splash window says, am I visible? If not, ignore the close event. So I would always close it, because it went through the login screen and showed it, and then it handled itself. So knowing the order of how the event listeners are, or first and foremost, knowing the order of how the browser windows are created, and then how the event listeners are mounted, will affect how they will actually be executed in the end. And one of the really important things here is to understand the event loop of JavaScript itself, and understanding which parts of the event loop that work will be done. Say if you want to do, what the fix was here was to set a timeout for the show the splash window. So it would be at the end of the event loop. And understanding how you can do work in every single step inside the event loop and move work back and forward will really help you in handling several windows in Electron. Another really infuriating thing was the AutoUpdater. You would assume that, yeah, if you use the AutoUpdater, it will work just like I expect. It will send a close event to my window, and I will be able to handle it from there. Unfortunately, it just terminates every single browser window straight off. It's like, everybody dies, and terminates the app. So you can't clean up after yourself, you can't do anything unless you actually stop the event from happening and handle it yourself. So what we did is, whenever you get an update or you get a message about an update, you take the event, make a callback, put it on a global object, and then we call it when we're actually ready to exit. And that way you are able to do what you expect it to do. And that is update when you have actually closed your application. So we give the user the option to keep working or actually close immediately. If the user chooses to keep working, it will silently install afterwards. And one of the things that I found when I was working with this is a lot of my problems stemmed from trying to do things synchronously when they were asynchronous jobs. So, I am working on a way of queuing up work that are asynchronous with requirements to each other. And I will probably publish it as an Electron package afterwards, or afterwards in time. What I'm thinking of is every single task you want done, or you can make what I called in the description the Electron boot sequence. You say, I want this and this and this and this and this to happen. I don't matter which order that you do it. All should be asynchronous. But some of the tasks have requirements. And every single task should emit back, I am done, and you can execute more work afterwards. And this way, our booting of the app would be much easier, because you would just make a task for starting the hardware server. It would go and do its work itself. Nobody else would have to care about what happens. It would report back and be more black box that way. And whenever I have time, I try to put in some hours. And if anyone have any ideas on how to do this, I'm very interested in hearing it. And that's me. Any questions? Yes and yes.
Yeah, so what was your motivation for actually, oh, right. Yeah, so what was the motivation for having a desktop application? Why couldn't this stay as a web application?
In general, it was to give the user a single application to run. And secondly, you have to have the hardware, have to be able to connect to the hardware. Because if it was a web application, you wouldn't be able to start the hardware server on your machine. And then you would have to pack and download the hardware servers separately as well. And it would be much harder to actually communicate between them. You could, of course, say that this runs on localhost 3000 and just talk over HTTP. But this way, we actually have full control on the server, and we can make sure that you are running this version's server as well.
Yeah, could I just fill it in? You saw that cache machine that he had up there. It would be really hard for non-expert developers like ourselves to guard ourselves against some spammer suddenly shooting out 1,000 kroners from that. Yeah, it's because we're not smart enough to put it online, exposed to the entire world. So yeah.
Having now worked with Electron for a while, do you have newfound respect for the developers of Slack and Discord?
Oh, yes. So much. The biggest difference, I think, between is running several windows. If you have only one window, it's much easier. But whenever you have to use several windows at the same time, the communication becomes much, much harder. I think that was it.